Hey everyone, today we'll be going over how to solve chemistry problems all under 5 minutes, and without any further hesitation, let's get started. Since chemistry problems cover a wide range of topics, this is how we're going to break down our following lesson. We're going to start with an example and build upon it. And say for instance we have a pile of wood chips, we would account for the following chemical equation. Now those pile of wood chips would contain a certain amount of a substance we are looking for to be able to start our fire, in this case cellulose. And we need to find a certain amount of grams we need of cellulose to start a fire. Now to account for how a chemical reaction actually synthesizes, we can analyze such by using stoichiometry, which define the relationships between both reactants and products. So in chemistry, we rely on the metric system. A big majority of chemical calculations deal with fractional unit conversion. For example, now in stoichiometry, what we typically do for fraction unit conversion is that the amount that we actually want to convert to, we typically put at the numerator at the top, and for what we are trying to convert directly, we put it at the bottom, so that way units can cancel out and we can get our desired results. Based on the formula, we need a certain amount of oxygen to be able to actually coincide with at least one given amount of cellulose. Now, if we're looking to get the exact amount of grams of oxygen we need, we are going to need to do the following. First, have the number 6, which represents the number of moles that we have for oxygen within the given equation, and then we need to segue over to our periodic table to find the molar mass. To determine the molar mass of a given substance, we first need to find this specific element that we are looking for on the periodic table. Now, the periodic table is organized based on the element types and how many valence electrons a given element can give. Here, we have the following. We have alkaline metals, alkaline earth metals, transition metals, basic metals, semi-metals, non-metals, halogens, noble gases, methanide, and actinide. Looking specifically at oxygen on the periodic table, here we notice the atomic number, the electron configuration, the symbol, along with the name, and the actual molar mass of oxygen. Now, oxygen is very unique because oxygen is also a nonmetal which pairs by itself as a diatomic molecule. Looking specifically at our equation, we notice O2. Now, as a diatomic molecule, this is how oxygen actually pairs by itself. We apply Lewis theory to be able to configure the bonds, knowing exactly how oxygen is able to pair by itself within nature. Now, a given element, especially from an anatomical perspective, is very, very small, and we currently use electron configuration as a tool to determine the position of a given electron / series of electrons. And this is the ordering of how we actually do our following electron configuration. Now, if we were to look at oxygen specifically and its electron configuration, we notice the 1s orbital, 2s orbital, and 2p orbital at the same time. Now, going back to our wood chips example, we currently have the formula over here. And since we already know that our molar mass for oxygen for just one mole of a given element is going to be 15.999, but since oxygen is paired by itself, we then pair the oxygen together and we multiply oxygen 15.999 times 2, since oxygen is paired by itself as a diatomic molecule, and since we have the 6 coefficient, which represents the number of moles, we multiply 6 times the amount that we have multiplied with 15.999 times 2. Altogether, we should get 192 grams for oxygen. Now, notice that in particular inside of our equation, that we are dealing with cellulose and oxygen, and our products are going to be carbon dioxide, water, and heat as a combustion reaction. Now, since we are dealing with organic molecules and that we have cellulose reacting with oxygen, there's a good high probable chance that we will get carbon dioxide and water as our products. Notice that we also have coefficients on the right side and the left side. If we were to break down each of the following individual elements for our reactants, we would have 17 oxygen, 10 hydrogen, and 6 carbon. And because of the law of conservation of mass, we need to have the exact same amount of substances for our products as we do for our reactants. And so that is why in particular that we would eventually have water and carbon dioxide with the same amount of elements that we have for our reactants. And we can apply the same type of principle if we want to figure out how much oxygen in moles we need to be able to actually output our following reaction. Since we know in particular by nature, if we were to pair carbon, hydrogen, and oxygen all together, there's a good chance we would probably have carbon dioxide and water, and those would be our following products. And we can actually determine that, hey, because we have a certain amount of hydrogen, we know for a fact that that eventually will have to be converted over to our product side. And using reverse engineering, we can actually figure out the amount of oxygen that we need ultimately. Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure to feel free to please like and subscribe. If you have any questions, comments, or requests, please put them in the comment section. And as always, take care. Cheers. Bye-bye.